This key is divided into two pieces. This is page 1. So first, let's take a look at example 1. And for example 1, they give you this function, which can be then simplified algebraically by factoring the numerator, and it divides out that negative x minus 2, which says that at x equals 2, this function's undefined. So if you remember, this is when there's actually a hole in the graph, and you can see that hole here. So let's take a look at the limit, and we want to take a look at the limit from the left and from the right. So if you recall, as x approaches 2 from the left, we ride the function and look at the y values. What's happening from the left? It's going to y equals 5, because this is the point 2,5. And then as x approaches 2 from the right, what's happening? Well, this function is coming down in this way, and what's happening to the y values? They are also approaching 5. So as x approaches 2, and this is from both sides, the y values are approaching 5. So that means that the function limit is 5. Let's take a look at example 2. And for example 2, we've got the same function, but you can see here, instead of there being just a hole here, they're saying when x is equal to 2, that's going to give you then a jump or a point right down here where this is the point 2, 1. Now, does this change the limit at all? And the answer is no. As x approaches 2 from the left, the y values still approach 5. As x approaches 2 from the right, the y values come down and approach 5. So as x approaches 2 from both sides, the y approaches 5. And so therefore, the limit is 5. When we take a look at the next example, we've got now a piecewise function that is in 3 different pieces: x less than 2, x greater than 2, and x is equal to 2. And what this means is that when x is less than 2, we're going to graph y equals x plus 3. So that's this line over here, y equals x plus 3. And when x is greater than 2, this line, we are going to graph y equals 4. Now when we take a look at the limit, we look from the left. So as x approaches 2 from the left, what happens? The y values are coming up and they're approaching 5. So as x approaches 2 from the left, f of x, or the y values, approach 5. And what happens from the right? As x approaches 2 from the right, we travel along this function here, and it approaches then the y value of 4. So it approaches 2, the x values from the right, the y values, or f of x, approach 4. Now what this is saying is that the left limit is not equal to the right limit, and we know if those two limits are not equal to each other, that the limit does not exist. Now for our last example, we want to really rely on the definition of limits. And the definition is saying that if the left limit equals the right limit, then that limit of the function as x approaches that value for x is equal to whatever number both of those are approaching. So this first guy here, this one, is asking you if the y value is equal to the limit, and this should say the limit as x approaches a of f of x. This is the y value at x equals a. So they want to know if the limit as x approaches a here is equal to the actual function value. Well, as we saw up above, if you look back up there to example 1, when we were approaching 2, there is no y value at x equals 2 because it's undefined. So therefore, over here we have undefined, but we still have a limit. When you look at the second one, we have a function who is defined at x equals 2. Here, at x, that function, which is example 2, the y value is equal to 1, but the limit there is equal to 5. And so in that case also, it is not true. But if you have a straight line that is just heading up here in some direction and you're looking at x in the middle, then your function value is going to be equal to the limit. And so this guy is sometimes. Let's look at part B. The limit as x approaches a from the positive is equal to x approaches a from the negative. So the limit from the right is equal to the limit from the left. Is that always, sometimes, or never true? This guy, and you can tell from example 3, there's one where it is not true, where the left limit does not equal the right limit. And so this is sometimes true, because sometimes we have them equal to each other and sometimes we don't. For the next one, it's telling us that the limit exists. Well, if the limit exists, then we know the right and left limits have to be equal to each other. So this one is always true. If you have a limit, those left and right have got to be equal to each other. And when you take a look at this one, this is saying the left and right limits are equal to each other and they're equal to k. Then the limit is equal to k, and that one is also always true. So that's it for the front page. Hope you're having a great day.